Now starting, all attendees are in listen-only mode.
Welcome everyone, and thank you for attending today's webcast, Inventor Advanced Surfacing Tools. Our presenter today is Kendrick Cooper. He is a solutions engineer with Hagerman Company. We're also joined on the line by Mark Dooley. He is also a solutions engineer with Hagerman, and he's going to be in the background to answer any questions that you might have as we go. Before we begin, I'll let you know that you are in listening only mode, so if you have questions during the presentation, you just type those into the question panel, which is located on the right-hand side of your screen, and they will be addressed throughout by Mark, and at the end of the presentation, it'll be a Q&A time. As we close down the session today, you'll be prompted to fill out a short survey. We do ask that you take a few moments to fill that out for us. And also, everyone registered will receive a follow-up email tomorrow, which will contain a link for the recording of today's presentation. And now I will hand things off to Kendrick.
Is a rarely used workflow of surface modeling. And one of the first questions we always get is, well, what's the difference? This is the only slide I have, and then we get straight into the live demonstration. The difference between solids and surfaces is key as to what you're wanting out of your CAD model. Depending on what you want to get, how much time you want to invest, that tends to determine which workflow you're going to go with. For surfaces, they have no mass and no volume. They have nearly a meaningless material assignment. You can assign a material to them, but its impact is not the same as what it would be with solids. It is useful information down the road, but not immediately. The best way to think of a surface, what is a surface? Think of it as a very infinitely thin sheet of paper. That's really what you're working with. It defaults to a transparent display. You can turn that default off. There are no interference detection abilities in an assembly. So if you've got an assembly that has some solid components and some surface components, surfaces will be ignored for interference detection. You also cannot 3D print a model coming out of Inventor that was built as surfaces. A lot of other products, that's what they deal with. They're polygon surfaces, and the way they write the information is a little bit different than the way Inventor writes a surface model. When you compare it to solids, solids have mass and they have volume. You can also assign various materials, including custom materials. For solids in an assembly, you can run interference analysis, you can run contact detection, and you can print 3D solids straight from Inventor. So now let's get straight into the demo. Surfaces come into play in primarily the part modeling environment. You can use surfaces to some extent, a minimal extent, in an assembly environment, but they primarily are focused around or inside of the surface environment. And the type of feature you're creating or the type of model you're creating, you will have to provide different inputs whether you're going solid or surface. So take, for example, if we look at a 2D sketch and we draw a closed rectangular box. When I finish that sketch and extrude, Inventor is going to default to make a solid box. There is an option where I can tell Inventor at the very top, can say switch from a solid to a surface. Now what that does is basically gives me a hollowed out box shape. So there's no front, there's no back. I do get all four walls around it. So it kind of looks like a fence, really. And that surface, if I say okay to that, that surface has no mass, no volume, no thickness. If I look at the eye properties in this, run an update, you'll see 0 mass, 0 area, 0 volume. Surfaces do have a center of gravity just based on their dimensional extents. So you are able to see a center of gravity for surface geometry. Now, if you draw a profile that is open, so what I mean by that is there's a break. So take the same box shape And if you don't connect the ends, that is considered an open profile. By default, whenever you create an extrude or a revolve or something like that, it will default to a surface object. You cannot switch an open profile to a solid. It won't work that way. It has to be closed in order to be solid selectable. But it will default to that surface entity. The advantage of using surfaces, there are some pros and cons for this. With using surfaces, you do have the ability of being able to do more work and more cleanup that you may not be able to do in solid modeling. One of the pros is your sketches can be a lot more simple than even in solid modeling. For example, one less line segment inside the sketch to create that open profile. You can take a surface and you can convert it into a solid with various options. So for example, if I extrude this surface, we're basically looking at a C-channel shape. One of the commands I can use is the thicken and offset command. Selecting each one of the faces, providing a thickness, we'll just say 1/4 of an inch. When I say okay, it converts my surface model into a solid because I gave those faces a material thickness. And you'll notice a change. You can tell what you're looking at by both the geometry in the modeling window and the icon at the top of the modeling tree. So if I undo this real quick, you'll see at the very top of the modeling tree, it looks like an orange blanket or sheet or quilt, if you will. And if I come back in here and do the thicken offset command and I'm selecting all 3 faces and providing a thickness, when I click OK, that icon is going to change from that quilt into a blue cube or cube shape. The color is going to change based on what version of Inventor you're working with. So you can start out with surfaces. You can incorporate surfaces part way through, most of the way through, even all the way up to the very end. And then at the very end, you can convert that solid or that surface model into a solid if that's what you're after. Another pro is with surfaces, the cleanup of model geometry tends to be a little bit easier to do. There's lower chance of a feature failure in certain circumstances. There are times where you can't get a fillet to apply on a solid model edge because of some of the blends that's taking place into other geometry. Whereas with surfaces, that's only going to be a factor if all of those surfaces are stitched together. That's one of the things to look at when you're creating surfaces is, are they seen as one contiguous blanket or joined or stitched together quilt, or are they some other broken up piece of geometry, separated surfaces, for example. So if we take a model like this guy right here, got a couple of things going on. We've got a little piece of feature material coming out here. On the back side, we have an open gap inside the model. This is an actual cutout, and you're looking down into the inside of the model. It's a surface model. There is no mass or volume associated with this. Everything zeroes out. Surfaces can help us clean this up. One of the things you can do is incorporate something like the delete face command, where I can come in and delete those faces, just take them out. And it leaves an opening. Again, you're looking down inside of the model, but I can patch that up. Looking across the 3D model ribbon, there is a surface panel that may be turned off on your interface. You can turn it on simply by right-clicking on the panel name, go to Show Panels, and one of the panels down through here is Surface. Make sure you've got it checked. Various surface commands on this panel. Stitching will take these various quilts of surfaces and in essence, it'll sew them together and glue them together as one entity or one unified surface. Then you've got things like patch that allows you to patch openings and patch up holes and things of that nature. Sculpt, that's a command that we looked at in a previous webinar I did about 2 years ago on some of the surfacing and freeform commands. I'll have a link for that a little bit later. But Sculpt allows you to use surfaces to either generate a solid or even cut and modify and take away from a solid. You have a ruled surface, which is very similar to a boundary patch. You get a little bit more control with a ruled surface that you don't with a boundary patch. Trimming allows you to cut surfaces using other surface geometry. You can extend surfaces based on the edge. You can replace faces of a model with surface topology. Even repair bodies or surface bodies that you may have imported, that you downloaded from somebody's website that have problems. You can take those over into the repair environment and work on those. And you can also download or open up a mesh model and convert some of those mesh faces into a surface. This is straight in the modeling environment. There are 2 other surface related environments that have many of the same type of tools, not necessarily the same exact tools. They work a little bit different, but those 2 environments are the construction environment and the repair environment. The difference between them is one of them, the construction environment, is an older piece of technology. It predates the repair environment. And actually, I'll just go ahead and show this part of it to cover it. We're in the demonstration portion now, but we're talking about the construction environment versus the repair environment. They allow you to take primarily a downloaded model. That's where you're going to encounter issues with surfaces that you have to fix in this manner. You download something from McMaster-Carr or Grainger or some vendor website. Sometimes there will be gaps in the surfaces or surface overlaps or overhangs or things like that. That's what the construction environment or the repair environment are intended to tackle. The difference between them is, again, one was an older environment. The repair environment is the newer environment. I will take a model into both of those here shortly to show you the difference. In this situation, I'm working with native Inventor geometry. I don't really want to go into the repair bodies or into the construction environment. I just want to use the surface commands themselves to fix this issue. Probably the easiest thing to look at for this is the patch command, or boundary patch is what it's also called. It allows you to select the edges to create a patch in that area. Now I can try to incorporate this, but when I select all of the edges, I get some very weird, lofted, bendy, warped shape. That's not going to give me what I want. So you got to be very careful when you're using some of the surface commands. In many cases, the less that you select, the better the result is going to be. So I'm going to pick those 3 edges for this workflow. Then I'll just apply that. The next thing I'll do is pick the arch. That'll give me a surface in that area. And what I can then do is start using some of the trim commands. So I want these to clean up where they mesh. Well, that's where the trim option is going to come in, to where you can select a surface to cut with, and then select the bit of the surface you want to remove. So I'm actually using the plane surface that was created in that arch as the cutting tool or the cutting edge. Then alongside that, I'm going to remove that little bit down below and get rid of that, clean it up. So I'll just apply that. I'm going to keep going because there's more cleanup I've got to do. I can use the remaining planar surface here on the angled face as my cutting tool, and now I can remove that bit of the arc plane, if you will. I can remove that bit that's down inside the model and get rid of that. The other thing you can continue on doing is using that trim command. You can still say, well, we're going to cut out using the entire surface body is really what you're doing, using the entire surface body. And now we're going to remove these little bits in here to get rid of those pieces. And that gives me a nice clean patch. Okay, so you can see the edges, but when you solidify this, they're all going to go away. Right now, they exist as 2 separate surface entities. If I look over in the modeling area, I've got boundary patch 1, boundary patch 2. You can right click on those and you can turn off their translucence, so that helps to see them. That helps you find things a little bit better. You're not seeing through the surface now and seeing the internal shapes and geometry of that component or of that part. Then you can also stitch those two together. So I'm just going to stitch these two surfaces. Gives you some information about the stitch, looking at gaps between the surfaces. You can set a maximum gap or a maximum tolerance, if you will. You can also run an analysis to show any kind of edge collisions or any kind of edges that are near tangent but not quite tangent yet. You can also choose to maintain it as a surface. This is an option that usually comes into play at the end of the modeling operation. If you're trying to stitch a lot of surfaces together and make a solid, you're going to want to leave this option turned off. But if you need to stitch these together and do more surface work, then obviously you'd want to maintain it as a surface. So I'll go ahead and apply that. And now we have a stitched surface over in the modeling tree, and it consumed the two boundary patches. So it's now seen as one entity. I could do the same thing over here on the other side to patch that up if you wanted. So when I patch with those edges and just select all four, and it gives me a nice clean patch, I can then come back and choose to stitch all of these surfaces, the main body, the two boundary patched areas, and say apply. When I do that, it fills in all of the openings. There is a little bit of an error right here that I missed. There's one little surface piece that I did not take care of. So I probably have to go back in here, unstitch or undo, and come back in and take care of that little piece. So it's just one little piece that I missed. But when you stitch them all together, when you do all that cleanup, that final stitch, if there's no gaps or no errors like that, what we just saw, it will convert this surface model into a solid body. We're actually going to see that in more detail in just a minute with a piece of imported geometry. There are some limitations with surfaces. You have the drawback that some commands will not work with surface geometry. Not all commands can utilize it. So if I look at, for example, well, I could just actually do a block if I wanted to. So if I sketch out a rectangular shape, I extrude that as a surface, not as a solid. So if I extrude it as a surface, I've got an open front and an open back. Of course, I can, boundary patch that. Boundary patch the back. It is still maintained as a surface. If I try to shell, can't do that. The shell command requires a solid mass volume. That's one of the commands that does not work with surfaces. Direct edit manipulation does not work with surface geometry. So if you're dealing with imported geometry, imported models that come in as surfaces, you cannot use the direct modify command to modify those surfaces, to shrink down a drilled hole or draft out a face or something like that. You've got to get that converted to a solid first. Then you can come back and use direct. Emboss is another command that will not work with surfaces, as well as the rib command is one of the commands that will not work with surfaces. You can take any solid model and convert it into a surface by simply using the delete face command. When you invoke delete face and pick just one surface entity, I'll just pick this one here, the end of the cylindrical tapered bore. I am not choosing the heal option. What the heal option tries to do when you select faces to delete it, it tries to remove that face and rebuild the geometry to maintain the object as a solid. If I leave that unchecked, then all it will simply do is blow away that face. It's now gone, and it has converted my object from a solid to a surface. You'll notice at the top of the modeling tree, it's the surface quilt, and on the physical properties, there's no mass and no volume. I also have that opening right there in the center. So again, the rib command will not utilize any surface geometry. I've got the sketches right there for the rib, but I've got to have that solid body in order for this to work. So with the surface commands, a lot of times what you're going to use them for is to either edit something you already have to gain access to some information or some kind of volume, or you're going to modify imported geometry. So if we look at a natively created Inventor model, this is just an indicator switch for a machine. It's going to be made in molded plastic. I need to know, this is going to be the mold portion of it. I need to know how much volume is in here, how much empty space or how much of the void. And the way I can do that is I can either directly edit the base model here, or I could actually derive this into a new part so it kind of stands separate. The derive command or the derive workflow has its own little gotchas, if you will. If I start a brand new part and I derive in that component, get out to the right folder. If I derive in that switch mold, just accept the defaults, I can make all of my modifications on this, no problem. Those modifications would be the same here in the derived component as though I were making them back here in the source model. The beauty with the derived workflow is the source model is unchanged, it's unaffected. So this gives me a standalone model that is related or linked back to the source. So if the source changes and updates, gets revised or whatever, my derived component will also get revised. What I can do to gain access to that volume of information, I need to first start blowing this thing away, deleting some faces, getting rid of some geometry I don't need. I don't need any of the outside faces, so I can use the delete face command, not select that heel option, and just get rid of the outside extent faces that I do not need. So just a couple of selections, say okay, and I'm left with the surfaces of that internal void. And I've got a little cleanup I've got to do, yes, but it's a start. So the first thing I'm going to look at is either applying a boundary patch or using the ruled surface option. With the ruled surface and the boundary patch, if you're not careful and you choose the automatic edge chain for the different options of a ruled surface, you may or may not get a result. In the boundary patch, it tries to force a result, and you can get some pretty wacky results when it starts selecting everything and tries to apply it. What you're seeing is it connects all of these surfaces, but kind of tapers it down and lofts it down and goes down into the internals. That's not what we want. So you got to watch some of the options in both of these commands to make sure you're selecting and isolating only the geometry you want to work with. So for this example, I'm just going to select the top edges here. And that gives me a nice flat face across the top. I'll go ahead and apply that. And select the edges here in the front, just to give me another wall edge across the front. I got a little cleanup to do with both of these. Again, they are boundary patches, they are surfaces. I can turn off the translucence and that helps. I've got some cleanup to clean up around the corners here. I've also got to get rid of this flat piece out here that I don't need as part of the volume. There's nothing there. That was just a rest for the mold. So to do that, I'm going to use the trim command. With the trim command, my cutting tool is going to be the body, the actual stitched mold surfaces. That's going to be what I'm going to use to cut the profile. And then what I'm going to remove, for one, is going to be these small little bits around the corners. And then I need to remove this front piece here. So I'm going to do the same thing. Trim this out using the front face as the cutter, and I can remove that front little landing piece. So that leaves me the void here. Still got a little bit of cleanup I got to do on those, but I can then use the stitch command to stitch all of these together, and that will give me the volume of this component. This is the workflow when working with native geometry. Now, what if we import something? Let's say I've downloaded some kind of housing from one vendor website, and it's a step file. When I go to open that step file, I'll go ahead and just convert it. Obviously, you want to try to look for any solids if there are any. Look for surfaces. Sometimes you might want to bring in the wires as well. Various import options you can choose. When I say okay, it brings in the geometry, and I can tell immediately this is entirely surfaces. And the reason I can tell that is because it's translucent. I can also look in the tree and I can see a composite. This is a composite surface import. Good things and bad things about composites. Surfaces tend to be a little bit overwhelming for a lot of users because we don't use them very much. They tend to focus in more of an advanced modeling approach, if you will, more nitty-gritty, more fine-tuning. You do have a lot of control with surfaces, and you can create some more advanced shapes starting out with surfaces than sometimes you can starting out with solids. So that's how they can be a more advanced set of commands. With something like this, we need to repair this. First and foremost, I need to get it to where I can see it well. And one of the easiest things to do is to turn off that transparency or turn off that translucence. That may help, that may not be enough. One of the nice things is you can also take your composites or your surfaces and you can change their appearance to something that shows more detail. So for example, if I switch it to, I think black cast shows up really well. Because of that texture and those lines, you can see a lot of things very, very clearly. So that'd be my first bit of advice is get the colors adjusted to where you can see what you're doing and see what you're working with. So now that I can see the details, I'm actually able to look inside and say, okay, well, we've got an opening here. We've got a surface that failed to translate whenever they built the export. There's one failed area. I see what looks like several surface breakups, but I can tell as I move around, the texture's kind of getting animated, if you will. When you see an animated texture, you tend to have a face on top of a face. So what we're looking at right here is there's a small face and a large face overlapping on each other. These kinds of issues, they primarily happen because whoever built the export did not choose the default options. They usually will go in there and they'll tweak something and it builds some, we'll call it unhealthy geometry. We can fix all of this and we can still use all of this, but that's usually why these things happen. Or you opened up an IGS file, which is probably one of the worst native files you can use for communication. It's a lot better to use a STEP or even a SAT file. For that matter, if you can get the native CAD file, we can open a lot of their native CAD files. We don't get access to the history or the features, but we at least get the geometry that we can use. That's probably the safest way to open another model. But in this event where we get errors like this, I mean, we've got surfaces that are overlapping, we've got missing tubes, we've got bits and pieces here, we've got a lot of these bore diameters aren't even connected. There's an inside bore and an outside bore, and there's no tube in between them. We see this a lot of times when that particular bore or that particular diameter is a threaded feature in that software, and depends on how they build that threaded feature. If it's a simplified or if it's a helical cut, there's various problems that can arise with sending out those types of features in a neutral format. So you got to clean this up. Various ways to do it. You could use the traditional surface commands. One problem with using traditional surface commands, they create a history item in the tree. Now it can be a plus, it can be a minus. It can also clutter your tree with a lot of steps that you don't need. Now, if you need to go back and undo or tweak something, that can be a benefit. You've got it right there in the tree, go back, edit that feature, make an adjustment, you're good. But if the cleanups are going to be simple and you don't need to track that history, that's where the composite or the repair environment are going to be of most benefit. I say composite, the construction or the repair environment are going to be the most benefit. The easiest way to get to the construction environment is to take your composite, right-click on it in the modeling tree, and copy it to the construction. Notice what that term or what that command says. It's copying to the construction. It's not moving the original. It's not translating it over or importing or anything. It's taking what you have and just putting a copy in a sub-environment in Inventor. So you're going to have two. You're going to have two of these objects there. When I copy this to the construction, there's a new folder that shows up in the tree called construction. Now, this is the older environment that we've had in Inventor for a long time. In order to get in here and make edits, the first thing you want to do is you want to take your original composite and turn off its visibility. You want to get that out of the display, get it out of the clutter, so that now you're only looking at the geometry that was copied to the construction environment. The way you get in here and make changes, you double click on that construction folder, that takes you into the construction sub-environment. If you look at the surface panel, you're going to see a lot of very similar commands. They are not the exact same commands. They function in a similar manner with some differences in their options. In here, it's called boundary patch instead of patch. A lot of the same kind of options in here. Intersect faces is slightly different. Boundary trim is a little bit different, not much. Then you've got things like edit regions, it's the same. Extract loop, exactly the same. You have stitch and you have unstitch. We don't have unstitch in the standard modeling environment. There's no option for that. You do have the option to quality check your surface, which hit or miss. Sometimes it picks up some things, sometimes it does not. If you select everything, let me do this again. If you window out and select everything, sometimes you'll catch some topology errors or some geometric errors or even some modeling gaps and things like that. Run and examine. Sometimes it finds things, sometimes it won't find even the most obvious things. Because what it's really looking for is it's looking for the health of that surface, not necessarily the health of the design. So you can look at this and say, well, first off, let's get rid of the translucence on this. You can look at this and say, well, I know there's not supposed to be an opening from here to here without a tube, but the quality check doesn't know that. It just sees this as surfaces. So it sees this area as a healthy surface. This is healthy. It sees these as healthy, even though they're overlapping. You don't want that. They are healthy quality surfaces. One of the first things you might want to do is unstitch everything. That's a good way of running an analysis and trying to check and see if anything else shows up. Again, sometimes it picks it up, sometimes it won't. When you unstitch, it breaks up all the geometry to where they're not seen as a conglomerate quilt anymore. They'll be seen as 96 different surfaces in this example. You can do things like edit region is pretty simple for patching up and sealing up holes. What the edit region does is you select a profile, and it can be a planar or cylindrical profile. When you get into wavy that are not cylindrical, you get into more lofted shapes. Edit regions may not be the way to go if you're trying to patch up an area in a lofted shape. It can give you some weird results sometimes. But on a planar surface or a cylindrical surface, it's prime. It works great. So I'll pick the main side face here. That's the region I'm going to be working with. And I want to define the profiles or the outlines. Well, for one, it's going to be the main face. That's going to be the main confined area. Then I'm going to select the small circle in the center. We're going to patch it up. We're going to fill it in. And it fills it in as one contiguous surface. There's no different or broken up surface in there. Same thing on the other side, patch up the same type of feature, works great. When you're looking inside a cylinder, you can use that tool to do the same thing. You want to edit that region of the cylinder, pick that cylinder wall, pick the bore hole inside, patches it up, nice and clean. So we'll come back, we'll convert this to a solid, and we'll come back and we'll manually drill these to whatever size we need or whatever size they're supposed to be. Because that could be something that we might want control over. We're downloading this part, but we may want to change the bore sizes and things like that. A few other issues in here, another disconnected face, using edit regions helps you clean that up real well. You can also use things like extract loop. You can extend faces out. What that allows you to do is if there's a gap between one face and another, you can grab that face, apply an extension amount, and you can pull that face out even further. The downside behind the construction environment is a lot of the new graphic utilities that allows you to grab a face and drag it. Those don't exist in this environment because it is an older environment. So you can do things like this to extend a face out. You can select a face, you can hit the delete key, maybe select the cylinder, hit delete. You can start cleaning up, and you'll notice over in the tree, there is no history. There's nothing being tracked or recorded. So this allows you to clean this model up nicely and neatly without all of the hubbub and fluff that can clutter up your modeling tree. The difference between the construction and the repair bodies environment, a lot of the same commands, but the repair bodies utility has, or the repair bodies environment has a utility to diagnose surfaces and surface issues a little bit better. You're going to stay in the same modeling area. You're just going to repair bodies, select that imported body, and it will take you into a repair sub-environment automatically. So it saves a couple of clicks. One of the first things I advise in here, you can change the color if you want to. Again, that helps you see things a little bit better. But one of the first things you probably want to do when you come in here into the repair environment on a piece of imported geometry, you could search for errors. It's probably not going to find any, or it may find a couple. The first thing you really want to do is unstitch the geometry. You want to break it all up because right now it's seen as one composite. I need it as individual surfaces because the way Inventor interprets composites, it interprets composites as the healthy unity of the surfaces. It doesn't see individual issues inside of a composite very well. Once you break that composite up into individual surfaces, you can really start to dig in and see some of the problems. This may take a couple of times to unstitch, maybe restitch some things together. That's the other thing. If you run an unstitch and no problems show up, try going back and stitching it together. Maybe it's not seeing it because it's not seeing the surfaces interfere. With the stitch command in here, you'll see there's a lot more controls in the repair environment than what we had in the construction environment. You can still look for certain types of analysis for edge issues, edge tangencies, edge gaps, unstitched edges. You can maintain it as a surface. You can fill in gaps that are below a certain size. This utility is phenomenal for any kind of imported geometry that has gaps between faces that don't touch. So when I say, okay, now that I've stitched it together, it comes back and it says, okay, we've got one quilt and we've got some edges, and it breaks down the issues that it finds. We got some edge issues, we got some vertex issues, we got some overlapping faces. So the repair environment can give you a little bit more information than what you get out of standard Inventor or out of the construction environment. This allows you to at least isolate, okay, well, here's some intersecting faces. What's the problem? And it highlights it, and you can go in there and see what's going on. Even things like overlapping faces. There's a few overlapping faces in this. Face orientations that may be backwards because you can flip the normal of the face. It may be going the wrong direction. This is evident if you go and try to sketch on that face and extrude that profile, it'll extrude the wrong way by default. So the repair environment allows you to come in here and fix these issues much the same way. You can run intersecting faces to unify faces. Sometimes you're going to run into issues if you select them in the backwards format or if they're not even overlapping, because that's one thing I did when I stitched it. It pulled the overlaps out. It got rid of that overlapping issue. So now we're just looking at two faces right here instead of this longer face being underneath the shorter one. So coming in here and running an unstitch or running a stitch can automatically, if you will, solve a lot of those issues. If you're looking at things like extending the faces or edit the regions, they still work the same way as what you have in the construction environment to fill in those holes. You can still come in and just select a surface and delete it. That'll simplify, again, the history because there isn't any. You're building this model. Once you get everything fixed, then when you're done, you're going to run a final stitch, and it's going to unify everything back together as one quilt. And then if there's no errors or issues in that model, there's none of these things. You go through and you fix every one of these face orientations and you fix all of the different gaps and stuff like that. Once you get all of that done, that final stitch will actually convert this into a solid. You just have to fix every one of these issues first. Something like this, you could probably fix pretty easily if you come through and you work with the edit region, you work with intersecting faces, and you work with boundary trim. That's really what you're going to get into a lot trying to fix these surfaces, is you get a lot of overlaps and reversed normals. If you do the reverse normals, you can flip them around. Sometimes that'll get rid of them, sometimes it won't. Intersect faces and editing those regions tends to be your one-stop shop for a lot of the issues of downloaded components. And again, it just goes back to how that model was written when it was exported from whatever software. It depends on the options that they checked and they tweaked during that export. It's really what it comes down to. All right, so again, outline real quick the pros and cons. Pros with surfaces, working with surfaces, they're simple sketches. You don't have to have a very complex sketch with all kinds of nooks and crannies and turns and fillets and chamfers and stuff like that. Very simple sketches to start out with. You're going to have more sketches in a surface model than you would a solid, which can give you more control in many respects. The cleanup is pretty easy because you're working with pieces of surfaces. There is a little bit less chance of a feature failing to compute. Probably one of the most common ones that used to happen is the sweep command. If you swept along a curve and the curve was too tight of a radius, that profile is turning back onto itself, and you would end up with what's called a self-intersecting loop or self-intersecting sweep. The surface command had less issue with that than the solid form of it did. A few years ago, they changed the sweep command and they enhanced it to where it doesn't have that issue as much as it did, no matter what way you go, surface or solid. So that got a little bit less evident, but you still have situations like that where the surface command is going to create it and just go about its day. There's no immediate mass with the surfaces that you create. That's a pro because maybe you're making a model of something that's going to be lifted. You're actually designing a new hoist or a new crane or a new cradle to carry some kind of weight or some kind of object. But you don't want the mass of what it's carrying to be factored into the assembly. That's one of the advantages of working with surfaces. The mass of a surface doesn't exist. So an assembly that contains a surface doesn't pull any mass from that surface model. So it doesn't have an impact on the assembly overall mass. Also, in a drawing view, one of the pros is surfaces don't show up by default. We have to go through a couple of clicks to get those to turn on and display. You can also set a component in an assembly. You can set it to be a reference component, and it is very much seen as a surface. Its mass does not impact the assembly, and it does not automatically show up on a drawing view or a bill of material. The result in the drawing environment for a reference component and a surface component, they're very much the same. One of the cons about the surface model, again, not all commands can work with surfaces. That's one of the things that you'll find kind of a brute force method. Does this command do this? Does it work with it or not? There can be more steps to editing a surface. There can be a lot more steps to editing a surface. The type of model geometry you can get from a surface model can tend to be, if you put the work into it, can tend to be a more advanced type of model. You can get a lot more intricate surfaces, no pun intended, out of a surface model than you can out of a solid. It's going to take more steps to do it, but you can get a much cleaner flow in many cases. One of the cons about surface models, it's a common popular opinion, they're complicated. And yeah, they can be, but once you get in there and see the commands and see what they can do and see what they can do for you, yeah, you get pretty comfortable with it pretty quickly. There's no immediate mass. That could also be a con. It's a pro and a con depending on the situation. Not having mass of a component, that can be an issue if you're trying to create a cradle of something and you want to see how it's going to balance in there. Well, you're probably going to need that mass to factor into that. Surfaces do have a center of gravity, so that can help with that, even though there's no mass. But with the surface commands, a lot of times you can convert that surface model into a solid in order to get that mass buildup. So I was going to show this. I don't know why it's not showing up. Maybe because I got it hidden. Yep, that'd be why. So let me unhide that slide and show. There we go. So back to the agenda real quick. I wanted to show the web link for the previous webinar. In the webinar I did about 2 years ago, we covered some of the same surfacing commands, but we dove into freeform surfacing, or freeform modeling in a very in-depth manner, covering a lot of the do's and don'ts when you're working with a freeform. Difference between traditional surfacing versus freeform. In freeform, you're working with T-spline geometry, which is akin to NURBS modeling or NURBS surfacing. It's more advanced than that. It's in a sense, you're working with virtual clay. You get a taffy pull effect, being able to grab faces and edges and just pull them and distort that surface topology. You can't do that with traditional surfaces. You're really working in a mesh model sense when you're working with freeform modeling. So you get a slightly different level of control. With traditional surfaces, you're going to have sketch lines, 2D lines, 3D sketch lines, to create that surface and control it. After that fact, you don't get to divide up the surfaces and control them independently and have them stay connected, much like you would with a freeform. So there is a difference between working in that traditional sense and going to something like the freeform modeling. It is a different way of thinking, and it is a completely different set of commands than what you saw today. So with that, we'll open it up for questions. Mark, how is the Q&A looking for this session?
So far, we only have 2 questions. Both needed a verbal answer more so than being typed back. So one question, Rolando has worked with models and assemblies that are composed of dozens of surface parts and wants to know if there's a way to convert them into solids at the same time. Yes and no.
Yeah, that's a tricky one. Converting all of them at once, no. there's no easy button way of doing that, especially if they have issues.
Right. If you're bringing in a step file that's already a surface via the import into an assembly, there is a way to convert that into a single surface, and then you can thicken it. But again, if it's got any issues, then you're going to have to go back to the single bodies and start working from there. So there's some not a good way to take a full assembly that is comprised of surface components and convert those into solids at the same time, no. But depending on the import process and how it was made or how it was delivered to you, how the vendor sent it or how you downloaded it, there could be an option to speed it up some. It would just depend on what the model looked like.
Exactly, and everybody needs to take a mental note. When you download or you receive a component from someone, a single component or an assembly, if you open it up in Inventor and it's coming in as a surface and it's coming in with issues, those issues are, there's multiple reasons why you have those surface issues. For one, Inventor calculates surface extents farther than other CAD packages do. We calculate surface extents and accuracies out to 8 or 10 decimal places, where some of the other products, they stop at 4 or 5. So we may see errors that they don't. That's good and bad. The other reason, most common reason you have issues is because of how they exported it. Whatever options they chose, they might have intentionally tried to do it to make life a little more difficult for anyone trying to reverse engineer their stuff. That's usually what we run into.
Yeah, they're trying to hide some components or hide some proprietary data that they don't want you to see, and so sometimes it can be a little tricky. Another question that came in was, can surfaces be flattened and printed to use as patterns, like a sewing pattern or vinyl?
That's That's a tricky answer. There's no blanket answer for that, yes or no. It's going to depend on what the geometry is. We are able to take some surface models and convert them into solids and pull them into the sheet metal engine to flatten using the sheet metal rules. There are limitations because of the sheet metal type of workflow. Inventor's not intended to take, you know, a rolled up ball of cloth, if you will, and flatten it out. I don't know of any software out there that'll actually do that accurately. But depending on the situation, you could manipulate the file to where we could get it to flatten with sheet metal. There's no guarantee it'll work because you get into things like lofted faces. If the material is not a uniform thickness, that's a big killer right there. Sheet metal will not flatten a non-uniform thickness model. Everything has to be uniformly thick. So if that's coming into play here, no, it's immediately out of the question. But if it's a uniform thickness and depending on the geometry, it's possible, not always. Any others?
And here is another question. Can we see this demo again? The answer is yes. Everyone that attended will receive a link to the video this afternoon or tomorrow morning, so you can go back and watch it at your leisure.
And at some point, I'm not sure when, it will be uploaded to either our YouTube channel or the Hagerman Hub. If you've not experienced the Hagerman Hub yet, go to our website. There's a menu pull down for it where you can sign up. You do have to sign up to become a member. I believe it's free, pretty sure it's free. And you get access to things in the hub that are not on our YouTube channel.
All right, and I don't see any more questions there.
All right, well, with that, I want to thank everyone for attending today's webinar. I hope you found it informative. I hope you were able to jot down the link to the other webinar I did about 2 years ago. If not, go to our Hagerman channel. It'll be right there on the Hagerman YouTube channel in the listing of all the videos. It was about 2 years ago, somewhere around 2018. So if you didn't get that link, jot down, by all means, go explore that and check that out. If there's any other questions that come in after the end of the webinar, we will get those from the GoToMeeting software and we will address those separately. Thanks, and I hope everyone has a great day.